Hi, this is Joyce Jason, and today I'll be explaining the fourth exercise, that is the usage of looping statements. So here I have 5 programs. So the first one is to create a multiplication table. So for that I'll just open the file. So this is the file name, and this is the program. So first here echo is used for printing a statement. So first it will be printed that enter the number of the multiplication table, like that number whose table has to be printed. So that the user will give the input and will read the input n. So now a for loop is used where it goes from I equal to 1, I less than equal to 10, and I plus plus. So till 10 it will be printed, and then a do loop is there where a is equal to expression and $n into $I. So then to print the table we'll use echo $n into $I equal to $a, and then after the loop is completed we print we write done. So now to run that we use sh space multi.sh. Enter the number of the multiplication table. So if I have to print a table of 4, suppose, and I enter, so the table will be printed. Similarly, there's one more program where we have to find the sum of the squares of the odd numbers. So I'll open the file, sum of odd. So I printed something else. I'll go back. I had given the wrong file name actually. It's sum of odd.sh. Yeah, so this is the program. Again here, first it will print enter the number, and then we'll read the input a. So initially r is equal to 0, and then we use a for loop where I equal to 0, I less than equal to $a, and I plus plus. Then a do while inside which an if else statement is there. So if expression $I mod 2, we use eq for equal to 1, then what happens is then b is equal to expression $I into $I, and then r is equal to expression $r plus $b. So to end the if statement we use fi and then done. So the sum of the odd numbers will be equal to $r. So we just go back. So I give sh here. Now enter the number. So I enter 5. So the sum of first 5 odd numbers is equal to 35. So first, what are the first 5 odd numbers? There are 1, 3, 5, 7 and 9. So the sum of all these numbers is 35. Now the next program is to find the sum of factorial of n numbers. So for that we have the program factorial sum. So I write factorial sum.sh. I hope this is ready. Yes. So again the same thing. First enter the number and then reads the input n. So initially I is 1, r is 0, and mul variable is equal to 1. So while $I is less than $n, then mul is equal to expression mul into $I, r is equal to expression plus $mul, and I equal to expression $I plus 1. So the sum of the factorial of numbers will be equal to $r. So just we can run and see. I write sh, enter the number, so I write 4. So the sum of the factorial of numbers is 24. Now the next one is the Armstrong number. So here I open the file. Sorry, again I made a mistake. It's the name was Armstrong. Yeah. So again, first we'll read the input C, where first initially x is equal to $C, a equal to 0, b equal to 0, and sum is also equal to 0. So while $x is greater than 0, we do a equal to $x in mod 10, and then b equal to dollar into $a, and then sum is equal to sum plus b. So x will be equal to x divided by 10. So if sum is equal to $C, we print it's an Armstrong number, otherwise it's not an Armstrong number. So we come out and we run the program, enter the number. So I write 153. So it should print, yeah, it's an Armstrong number. And again, if I want to run this, so enter the number, I give some other number, 254. So it's not an Armstrong number. Now one more program is, we have to print the Fibonacci series. So for that, we have the file name as Fibonacci.sh. Yeah, so here again it will read the input A till what number we have, till what series we have to print. Then initially x and y are 0 and z equal to 1. So first we'll print $y, then $z, and c equal to 2. So while $C is not equal to $a, then do b equal to $x plus $y plus $z. So b equal to, yeah, so then we have to print b, and then x will be equal to y will be equal to $z, and z will be equal to $b, and c will be equal to expression $C plus 1, and then it's done. So when we run this, enter the number till the series is wanted. So suppose I want till 5. So these are the Fibonacci series. Fibonacci series, like it's adding 3 numbers and then it's keeping on printing. So like this, all these programs are using looping statements. So that's all for this video. Thank you.